Let's prove this result by induction. So first up, we're going to prove that it's true for n equals 1. The left-hand side will simply equal 1 minus 2, 0, 1. And the right-hand side will equal 1 minus 2, 0, 1. And the left-hand side equals the right-hand side. So this is true. We're now going to assume the result is true for n equals k. So remember, we've shown that the first domino falls over. We're then going to show that the kth domino leads to the k plus 1th domino falling over. And that means 1 will mean that 2 is true. 2 means that 3 is true. Actually, it's going to be true for all values. So assume true for n equals k. Therefore, we can write down via this assumption that 1 minus 2, 0, 1 to the k is equal to 1, 0 minus 2k, 1. And we want to show that it follows that true for n equals k plus 1. Sometimes it can be quite complicated. It can be really helpful to substitute the k plus 1 in. In this case, not quite so much, but I'm going to do it anyway. When I actually did it myself, I didn't even bother writing this bit down. Because where I'm coming from is sometimes it actually helps to manipulate this expression. We're trying to get this right-hand side in a minute. So I could expand the bracket. So if I can get to here, sorry, that should be a minus 2. Then I'm there. Okay, so let's start from the left-hand side. And this is going to equal 1 minus 2, 0, 1 to the power of k multiplied by 1 minus 2, 0, 1. Of course, you could do it the other way around if you want. The order's not going to matter. This is where I use my n equals k, because we can say that that left-hand term is simply 1 minus 2k, 0, 1. So using n equals k result. And we're just left to multiplying out these two matrices. So this row by this column, we're going to get 1. Then this row by this column, we're going to get minus 2 minus 2k. That is looking promising. Then here, I'm going to get 0. And then finally here, I'm going to get 1. I've got to here. Just to finish, I'm going to write it as 1 minus 2k plus 1 and 0, 1. So therefore, true for n equals k plus 1. We've shown that this is equal to this, which is what we needed to do. So true for n equals 1. N equals k true implies n equals k plus 1 true by the principle of mathematical induction statement true for any natural number. Just have a little bit at the end that you add along these lines. It doesn't have to be word for word like I've written it. I've just got into the habit of doing that. And we're there. We've proven this statement. Well done.